What's up guys, this is LeetCode 11, container with most water. Given n non-negative integers a1 to an, where each represents a point at coordinate, this coordinate and vertical lines are drawn such that the two endpoints of line I is at ij and I0. This means the height of a vertical line. Find two lines which together with x-axis forms a container, such that the container contains the most water. You may notice length, the container, and n is at least 2. So there is an example here. We can see that two lines here, the red lines, are like a box. So imagine that there are no lines between the red lines, and those two red lines are like walls. So we need to calculate the area within these two walls, and that area will be the box that we can put water. So as the lines have different heights, we need to get the smaller one and multiply by the length between these two lines. So we can get the length by subtracting the right line, which is an index, by the left line, by the left index. Yes, I think that will be a solution. We can do that by, I think if we have two for loops nested, we can start here in the first line with the first for, and the second for we can start in the line in front of this first one, and we can start to calculate the area for every line in this index, in this array. So we will calculate first this line by this line. After that, we can calculate this line by this line, and so on. We will also need a result variable to update the result. And I think this is a solution with time complexity of big O of n squared, because we have a nested for loop calculating for every single index all the other indexes. Yes. But I think we also can have the solution by calculating two indexes, not in a nested loop. We can put a right index, and we can put in a left index and a right index, and calculate the area of these two indexes, and we can after that subtract the index with the height is less than the other. Yeah, I think that's it. So if the height of one index is smaller than the other, we can subtract it, and we'll get the indexes closer to each other, and when both are in the same place, we can stop the loop and return the result variable. Yes, I think this is much better, and the time complexity for this solution is big O of n. Yeah, I think that's it. We can try to write some code. Let's go. So I will not check if the height is valid, because their exercise is saying that the height will be at least 2. So let's start declaring some variables here, the indexes variables. So we will need the left index starting at the beginning of the array, a right index starting at the end of the array, and a result variable starting with 0. I'll do this with a while loop, while left is less than right. Okay, so now we have to calculate the area by multiplying the length by the height. So the length will be the right pointer minus left pointer, and the height will be the smaller height between the two indexes. So yes, we can get this by using math.min and math.max. So math.max to get the maximum result of result, and here math.min to get the minimum height between height of I and height of J. After that, we can multiply the result of the minimum height by the length. The length is right minus left. So let's break this line. Okay, so math.max of result and the current area. Okay, that's it. And now we can either go forward with I index or go backward with the right index, left index going forward or right index going backward. We need to check which of the heights is smaller. So if height of I is less than height of is not I is right, and here is left. So if this is true, I want to go forward with left, and if this is false, I want to go backward with right. And when I get out of this while loop, I want to return the result variable. And if we do not have any typo, I think this is the solution. Let's try to check the code. I is not I is left, and it's not J is right. Okay, so let's try to run again. Let's try to hit submit. Okay, so that's it, guys. As I said, time complexity here is big O of n, where n is the length of the input. And even if we are declaring some variables here, our memory complexity is constant because all these variables does not have any relation with height. So even if the height gets bigger, we will still declaring the same amount of variables here. So that's it. Thanks for watching.